Let's take a look at one more example for how to use the law of sines to find all the sides and all the angles of any triangle. Like we talked about in the last video, you're going to know to use law of sines if you have an angle-side relationship, an angle-side pair. So in this case, since I know both side A and angle A, I can use that to set up law of sines. And one quick note down here, when you have a choice of which angle you find, and you don't always have a choice, when you're using law of sines, make sure you find the smallest angle first. The reason is, when you do the inverse sine to find an angle, inverse sine on your calculator will always get you an acute angle. If the angle happens to be obtuse in the triangle, we won't be able to find that using an inverse sine. It won't find us obtuse angles. So in case there's an obtuse angle possibly lurking in your answer, make sure you find the smallest angle first. In this case, there's nothing to worry about because I can see I have an obtuse angle given to me, and a triangle, of course, cannot have two obtuse angles. Anyway, the point is, if you have law of sines, find the smallest angle first just to be on the safe side. So the way law of sines works is we set up a proportion. In this case, we'll do sine of 115, that's sine of angle A, over side A, its corresponding side, so over 20. Is then equal to, we don't really have a choice this time, I have to find angle B first. So let's do sine of angle B over side B, which I know. Side B is 11. Okay, so once, like we did in the last video, we're going to solve this by cross multiplying. This time though, we're missing an angle, so it'll work out a little bit different, but nothing too bad. I get 20 times the sine of B when I cross multiply this way. And using a calculator to cross multiply the other way, I would just type in 11 times sine of 115, making sure that I'm in degree mode. That comes out to be about 9.7 or so. And then, as we also talked about in the previous video, I'd recommend not rounding these off on your actual calculator. I round them off when I write them down, but in the calculator I don't clear it out. I just use the complete decimal that was given to me. Now, to find angle B, I'm going to have to divide both sides by 20 for starters. So once I do that, I find that sine of B is equal to about 0.4985. Again, the more decimals you can use, the better. Although don't round them off on your calculator. And then at this point, since I'm finding a missing angle, here's where I'm going to do an inverse sine. And this is what I was talking about. If your angle happens to be obtuse, you won't find it. You won't be able to find it using inverse sines. Inverse sines will only find you acute angles on your calculator. So just watch out. Make sure you find the smallest one first to avoid this. This means angle B comes out to be approximately 29.9 degrees. Make sure you include that degree symbol. Okay, so we got our first piece of information. Let me add that to the chart over here, 29.9. And at this point, we can start to find a lot more information. Since I know the angles of any triangle always adds up to 180 degrees, I can find angle C right away just by subtracting those from 180. That comes out to be 35.1 degrees for angle C. And now what I'll do to finish this out and find side C, let's do another proportion. So sticking with that one that worked out so well at the beginning, let's do sine of angle A, which was sine of 115, over side A, which is 20, equals sine of angle C, which we know is 35.1, over side C. So another proportion to solve. Isn't law of sines fun? When I cross multiply this way, sine of 115 comes out to be approximately 0.91 times C. And when I cross multiply this way, 20 times the sine of 35.1 is 11.50. If you need to pause the video and check these calculations for yourself, go ahead and do it. If you're just watching to see what I do, then it's fine too. Dividing both sides by 0.91, then I see that side C, my final mystery in this triangle, comes out to be about 12.46. So I'll add that to the chart, and I should have all my information. I've now solved this triangle. One quick thing I like to do to check is just make sure, since we know biggest angles are across from biggest sides, just check your chart and see if that's true. Yep, my biggest angle is across from my biggest side, and the reverse is true. The smallest angle and smallest side are also opposites of each other.